Hi, I'm Richard Whittle. I write for BreakingDefense.com. We're at the Association of the United States Army's annual convention in Washington, and I want to show you something interesting. Yesterday, we took a little ride in the Bell V-280 Valor tilt rotor simulator, which is on display elsewhere at the show. That's one of the competitors for an Army program called the Joint Multi-Role. It's an attempt to build faster, more agile rotorcraft. Now we're at the Boeing display here at AUSA. Boeing and Sikorsky are building a much different aircraft, a compound helicopter it's called, the SB-1 Defiant, and they have a simulator here too. Now Nate Morgan, a Boeing engineer, is going to explain to us what this simulator is, because it's not a full-up flight simulator, but it's going to give us a very interesting experience.
So right here we have a portable demonstration simulator. So we have the actual flight simulation modeling for the flight dynamics of the aircraft. However, we only have a simple flight controls layout for the purposes of demonstrating the maneuverability, agility of the aircraft, and the speed and range capability of the configuration. So in general, we have a basic set of cockpit displays and out-the-window visuals. And as I said, the flight dynamics are mostly represented according to our accurate flight dynamics model.
Yeah, so the point is, while this is not the elaborate sort of flight simulator of the sort we were in yesterday, Major Frank Conway, a retired Marine test pilot, is going to take us on a ride and show us what it'll look like to fly in the SB-1 Defiant. The Sikorsky Boeing SB-1 Defiant hasn't been built yet, but this is how it's going to look when they get it done. They hope to fly it next year or perhaps in 2018. And now let's go into the simulator. So, Major Conway, or if I can call you Frank.
Sure.
We're sitting here. What are we seeing on the screen here? And where are you going to take me in the SB-1 Defiant simulator?
What we've got you set up for is basically the Camp Pendleton, Southern California flying area. We'll take you up, let you see some of the handling characteristics that we envision for the aircraft. We'll take you through the mountains a little bit, let you see how it maneuvers, and we'll let you fly and let you get a feel for the aircraft on your own.
And Frank, how is this going to differ from an ordinary helicopter?
Yeah, so the primary thing we're talking about is increased agility through really nice control power in the rotor head, as well as an outstanding top airspeed that we're going to top out above 250 knots, so almost twice the speed of a conventional helicopter.
And the reason for that is this aircraft is going to have two rotors turning in opposite directions.
That's correct.
And a pusher propeller.
Yeah,
right?
so
and that's going to let us do things that an ordinary helicopter can, but the aerodynamics of rotors limit the speed of ordinary helicopters.
That's exactly it. So it's called a coaxial pusher prop. You've got the two rotor systems going in opposite directions, eliminates retreating blade stall, allows us to get out to those much higher air speeds. 11-foot diameter prop is what's going to give you that acceleration, and essentially almost an auto-rotative flight as we get up above 120 knots.
Okay, let's go.
All right, let's hit it. All right, you ready
Okay,
to
so
go?
let me, just for the viewers, we switched seats because this simulator only has the controls on the right-hand side, and you are a much better pilot than I. So let's go.
Okay, sounds great. So one of the nice things about the coaxial pusher prop is the majority of our mass is centered along the aircraft's longitudinal center line. So it makes maneuverability in the lateral axis extremely precise, very smooth. The quick stop left and right is very easy, makes it very maneuverable, agile. Suppose we were coming in on a short final approach and we have to evade enemy fire. You can quickly do that and reacquire the desired trajectory. Very maneuverable in terms of the pedal response, and quickly grasp the heading that you desire just through the heading hold feature. For acceleration, we have 11-foot diameter prop. And what we'll do is kind of a mix of a combination helicopter departure where we dump the nose a little bit, accelerate with the prop, as well as the rotor system. So with that, we'll get going from a hover. So I dump the nose just a little bit, get the prop running in, and you can watch down on the display as the prop system starts to engage. Above 80 knots, we put the collective on what's called the map, and I can take my left hand free, and I'm flying now with just my right hand. We have a little thumb wheel that allows us to control the pitch on the prop and controls our decel and acceleration.
So how fast are we going? How quickly?
Yeah, so we get up above 250 knots in less than a minute, significantly less. I don't think we're going to release the time right now, but it is a pretty eye-watering acceleration. As well, I did that one at a maximum rate where I dump the nose, pull the collective pitch.
And this is more maneuverable than a helicopter?
Yeah, so what you have is extremely stiff blades. You know, if you could imagine the aircraft was sitting here, we could actually do a chin-up on one of the blades without it deflecting very much. And a traditional helicopter uses some of that bending and flexibility to assist with the flapping and the dynamics. We do the opposite. We keep it very stiff, almost like a metal I-beam coming out. You could picture it with that level of stiffness. That way, when I make an input, the aircraft responds. There is no second and third order dynamics going through the rotor system, correct?
So put us down somewhere tight, fast.
You got it. So if we were going to do a decel, we just go ahead and get the prop running back. And I actually started it when you had the T and fast coming out, and we're already down at 112 knots from over 250 knots. I've got a glide slope picked out. I'll just come into a low hover above this little water feature. And with very minimal, I'm just putting in a little bit of nose up here at the bottom, pull some power, take the prop to a zero thrust position, and we're in a hover. So I didn't time that, but it'll give you an idea from when you asked for a decel to when we were in a hover.
And if you're going to take off quickly, does that prop come to a full stop and back?
So you've got a couple of options. One, I can manually dial it in as I need to. I set the pitch either forward, aft, or to neutral setting. Another option is I can actually command a zero thrust, which is nice. I can go from a full negative pitch to a single button press, and I'm now at a zero thrust position. That's a real nice feature.
So if you want to get out of a spot quickly.
Yep. Basically, again, do that combination where you dump the nose a little bit, pull some collective pitch, get the prop running out, and in the time I was just talking to you, we're up over 120 knots and accelerating. The map comes on, so now the rotor system's flying in kind of an auto-rotative state, and in that quickly, we're up over 200 knots. So pretty rapid acceleration, very quickly be able to get out. And the nice thing is, even at the very low airspeeds, we do have the ability to command very nice lateral inputs and displace laterally from hostile threat, maybe geographic terrain, that sort of thing.
How much fidelity do you think there will be between the computer simulation here and the actual aircraft?
That's a great question, and I think it's a valid one. We have obviously, between the two companies, have a long history of using simulation as a predictive tool. Our models are validated against multiple aircraft. As well, we have our own wind tunnel data that we feed back in to continuously update the model. So we feel it's got a very high correlation to what the actual aircraft will do.
So for all intents and purposes, I'm getting a ride.
You're
in the
flying
SB-1
it.
Defiant.
You are absolutely flying an SB-1 Defiant, and you can see it in the inset just off to the left there. But yeah, it's the actual aircraft, 30,000 pounds. It's got the rotor dynamics modeled. It's got the inflow through the prop modeled, all the aerodynamics. It's got the actual flight control laws. So
now, what if you want to get up high quick out of a zone where you're under fire?
yeah, absolutely. So we're zipping along now at about 220. I just pull the nose back, command about, let's call it 30 degrees nose up or so. Peg out at about 8,000 feet per minute on a zoom climb, which is pretty nice. Then we start to level it off, go to a steady state climb, somewhere north of 3,000 feet per minute. So that quickly, again, just in the terms of that conversation, we gain 2,000 feet of altitude. So pretty rapid.
And
We'll just level it out. And then it's the same in reverse. So here we are again, without much of a trade in airspeed, we're back at 200 knots. If I want to get a rapid, perhaps a gun solution, if I was flying an attack variant, I just roll the wings, get the nose coming down. Again, flies very much like an airplane, and I'm on target.
And we don't have a good representation of this aircraft to show, but it has stubby wings.
No, there's just basically the two side doors, a pretty clean fuselage, and if you wanted to do, I think where you're driving is an armed variant. We've got a separate model where it's a longitudinal, very narrow aircraft in tandem seating.
Okay. All right. Well, thanks a lot. Can now put us down safely somewhere.
Absolutely.